Thank you very much for joining us. This is the Discovery Clusters session on usage-based discovery. Today I'm gonna share my screen and give a presentation. The focus for today's presentation is to cover some sticking points that we've encountered in our cluster and opportunities for the community to continue to engage in this important topic. So I should be presenting now. The taking stock of our past discovery cluster activities, we've been meeting for the past couple years since we were rebranded Usage-Based Discovery. We've hosted 3 hackathons, and Chris has led 2 AGU posters from his past leadership of this cluster. And there have been numerous interns and the ESIP fellow contributing to the cluster activities over the past 2 years. And recently, NASA actually hired a developer to work with us and develop the usage-based discovery tool. This tool is, this is displayed here on the screen in the background. This is a landing page that you can find in the tool. And the tool's built on this very simple data model. You have at the top level, the usage-based discovery science topics, and the user selects those, and then they get to a menu of either applications or research articles. If they select one, then they come to this landing page, like you see here for the Marine Biodiversity Observing Network Pole to Pole Americas. And then for that, like each one of those little points on the map, if you can see that, those correspond to a data set. So this provides an intermediate level of discovery of data sets where we're putting in the middle of the discovery, the research article or application before you end up with a data set of interest. So this is a presentation that has been recorded previously, and I'll just play it for you. Vinny Inversa, who's that developer at NASA, is presenting this. Then we'll come back and finish this introduction.
Welcome to the usage-based discovery application. Right now, we're on the usage-based discovery page. You can see here we have a pretty simple list of topics. And the goal is to make this process of earth science data discovery as easy and accessible as possible. So we've avoided using any specific jargon or words that perhaps analytics or interdisciplinary standards will not be.
Is there any way you can boost the volume? It's very difficult to hear.
So click this button here.
Is that better?
No, and I'm not the only one. A lot of chat about being problematic.
I think when you share the screen, you need to also share video sound.
Sure, let me do that. Sorry about this. Share. I should have tested that. Advanced computer audio. All right, let's try this again.
Welcome to the usage-based discovery application.
Is that good?
Fantastic.
Over on the usage-based discovery homepage, you can see here we have a pretty simple list of topics. And the goal is to make this process of earth science data discovery as easy and accessible as possible. So we've avoided using any
Jonathan, can you share your screen as well?
specific jargon or
Oh. Get there.
This is sort of like usage-based discovery, discovering all the problems.
All right. Now we'll do By the way, did Julia Lane join us? Okay, well, soon she will. Well, we might have extra time in our agenda. We'll see. Okay, let's play this.
Now I can't hear it, Jonathan.
I'm just gonna
But I can't hear it.
one more time. Advanced computer audio and video. Let's say video, share video.
Welcome to the usage-based discovery application.
Do you see that?
Right now we're on the usage-based discovery homepage. You can
Perfect.
see here we have a pretty simple list of topics. And the goal is to make this process of earth science data discovery as easy and accessible as possible. So we've avoided using any specific jargon or words that perhaps a non-expert or an interdisciplinary scientist would not be as familiar with. So let's pretend for a moment that I'm interested in sea level. So I would click this button here. And this brings me to a page where you can see on the left-hand pane here a list of either publications or applications that have the topic of sea level. Let's say I'm interested in this one, rethinking climate change and their relationship with water. In the middle here, I have all the details on this particular publication. I have an excerpt from either a citation or an abstract. I can edit this publication if I think the details should be updated. I have the essential variable, which is essentially what the paper is measuring right here, which is sea level. And I can also go to the website of this publication to learn more about it. On the right-hand side here, I have all of the data sets that were used in this publication. So this is really useful if you want to perhaps replicate the work that was done in this publication or build on it. Not only do I know all this information about the publication, but I know exactly which data sets were used in that publication. So that's really great, really useful. I can click to see more information on these data sets with the See Dataset button. And this takes me to a home page where I can read more about the data set, how it was produced, and perhaps how to download the data set. If you're interested in learning more about usage-based discovery, go to our About page. You can read more about who we are, the philosophy behind usage-based discovery, and as it says down here, you can log in with your ORC ID and contribute to our graph database, which powers all of the content that I just showed you. You can see if you click this Explore button when you're logged in, you can actually see and visualize the graph database with all of our content. So this is a collection of topic, application or research publication, and dataset vertices that are all tied together by these edges and these relationships. So this is great if you're more of a visual person, if you want to explore some of these relationships that I just showed you. And then finally, we have a leaderboard. And this leaderboard's great if you're contributing and you just want to know how many data sets have I added, how many data sets have I verified, and things of that nature.
Okay. I'm going to reshare with my presentation. Okay. So I'll breeze through the rest of my slides since we lost some time there, but basically we came up with this controlled vocabulary of science topics that's broad, covers all different applications from earth science. We tested it by, we pivoted from applications to research articles because there's a known relationship between a research article and the data set through the DOI. And which is not always as easily found if you're looking at a website or application. So this helped us fill out that UBD tool that was demoed, and now this is what the graph looks like after 2 years. And it's working very well, partially because this is a very simple data model. The further research that's been conducted just recently, Chris and Vinny and others presented on this work where they were clustering the research articles and providing some intermediate level of discovery below the science topics, but above the specific articles and data sets. So it's kind of like an evolution here. We started with applications, research articles gave us a lot more data to work with. And now this clustering algorithm helped us organize all that data that we came up with through that exercise. So we're in this period of ferments. Ted Haberman coined this term. This is his graph from a 2015 presentation on metadata, and that very much applies here. There are a lot of different projects tackling similar problems. We're not yet at a place where we can put our energy towards this and be efficient and make progress. So we need to work on this some more before we can converge. And that's why I think this cluster needs to soldier on and continue to work. Here are some sticking points for us. We need to have vision and leadership to continue defining this topic. We need to continue to get cluster time from folks who are part of the cluster. And NASA's been picking up a large part, as is ESIP, of the funding costs for this. So the interns were funded through ESIP, and Vinny's time is paid for from NASA. And if that'll be critical for our success. And then we have this issue of manual data entry because it's a boutique application now that we use to test the concept. Before we can become operational, we need to get away from manual data entry. So the goals for this and the opportunities for us to work together is to develop more of a cross-agency data discovery tool, and that bring in agencies that fill critical gaps in the data lifecycle. So EPA is really heavy on the application side. And NSF has a broad mission like NASA, covering all different areas of earth science. They need to be at the table as well. But later on, we're going to have these breakouts, and the objectives for the breakouts, you can self-select into one of these three. You'll hear more about this, but you can either help us develop the messaging for usage-based discovery so we can get the word out and enroll people in participating. Now, one area where this cluster has been really effective is to share ideas. In this era of ferment, where there's a lot of people doing different things, it's good to have a place where we can compare notes and start to develop common practices. And then finally, there's kind of the researchy angle to this, like that clustering algorithm I showed you. Can we work on data science? Can we do machine learning? Do you want to just contribute content to the tool, or do you want to improve the user interface for the UBD tool? So those are the opportunities. I really welcome you guys to come to our cluster meetings in the future. Think about these objectives as you hear the next two presenters and their work, and then we'll come back together at the end for this breakout. So without further ado, I'm going to stop sharing and pass it to our first presenter, Madsen Langseth from USGS.
Hi, thank you. Let's see if I can share my screen. All right. It says participants can now see your screen. So is that true? Okay, awesome. Well, thank you very much for inviting me to present today. I'll be presenting on behalf of myself and my colleagues, Daniel Weefrey and Brandon Cerna, about PubLink, which is a tool that we built to help the US Geological Survey discover use of our data. And I brought it up at the summer meeting that we had this tool. And so Jonathan reached out and asked if I could provide a little bit more detail on the tool. So here we go. So in today's presentation, I will briefly touch on the importance and challenges of understanding data use. I'm going to introduce PubLink and describe how we use PubLink within the USGS to discover data use. And then finally, I'll go into a little bit of the technical details for using PubLink. I need to move this. I think, there we go. All right. So understanding how data are used across the scientific community provides many benefits to data authors, including building a better awareness and comprehension of a data set's scientific impact, use cases to direct future versions, and related scientific efforts. Now, effectively tracking when and how data are used in the literature through time can be challenging. And this is in part due to a lack of consistency in how data are referenced in the scientific publications and whether or not publishers index data citations. The Make Data Count initiative is encouraging publishers to implement standard data citation policies, including requiring that authors cite data in their references lists using digital object identifiers or other globally unique and persistent identifiers, as well as indexing these data citations with Crossref. So this initiative will enhance the ability of data authors to track downstream use of their data. And many publishers are adopting these practices. However, data citation indexing might not happen retroactively. So PubLink is an open source Python package that provides methods to extract and build relationships between publications and the data sets they reference. Methods are included to support pipelines for tracking existing and new relationships through time. The package leverages the Extract Dark Data, or XDD digital library and machine reading system, which was formerly known as GeoDeepDive. XDD is a digital library consisting of over 14 million publications, and it grows by some 4,000 documents daily through automated fetching mechanisms from multiple commercial and open access providers. So XDD is deployed over cyber infrastructure capable of supporting many different text and data mining applications. And PubLink uses the RESTful XDD API to search for mentions of dataset relevant terms, including dataset DOIs or titles within the full text content of the entire digital library. So this unique method allows PubLink to capture references to data sets that predate adoption of data citation principles and data citation indexing efforts. In addition to providing flexible full text search and retrieval of document metadata, the XDD API also surfaces snippets of text that surround the specified search terms. And this contextualization allows individual mentions of a target search term within the retrieved document to be assessed through both manual and automated mechanisms. So to understand data use at the USGS, we use PubLink to mine XDD weekly for mentions of USGS datasite DOI prefix, which is 10.5066 for USGS. When we find a new mention, we store the publication DOI that is referencing the datasite DOI as a related identifier in the datasite DOI's metadata. And there are methods built into PubLink to help support higher levels of confidence for finding these USGS DOI mentions, allowing us to automate this workflow. And I'll go into a little more detail on that confidence later in this presentation. So we then display the related citations in the USGS Science Data Catalog, which is our metadata catalog. And this enables end users to understand how a particular data set has been used in the scientific literature. So we wanted to try to get a sense for how many references to data we're capturing through this XDD tracking pipeline, which is pretty challenging to do. But we do have some data that allowed us to get an approximation of the percentage that we might be capturing. So when a USGS researcher requests a DOI for their data, we ask if there will be an associated publication using those data. And if yes, we ask them to provide the publication's DOI. We're using these USGS researchers and their associated publications as a proxy to assess how our researchers in general might be citing or referencing data in publications. So what we found a little over 70% of these publications are indexed in XDD. So right away, we know that XDD does not index all of the publishers relevant in our domain. We took this subset of publications that are in XDD, and we looked at what information was available in the publication's cross-ref DOIs, as well as whether or not the associated data DOI was mentioned in the full text of the article. So on the left, we can see that about half of the publications had detailed references listed in their cross-ref DOIs. Of those, a very small percentage of articles per year had the data DOI listed in the references available in Crossref. In contrast, on the right, we looked to see if the data DOIs were at least mentioned in the full text of these publications. And we found that around 60 to 70% of publications per year mentioned the data DOI in the full text. However, there is still a substantial percentage of publications that are not mentioning or referencing the data that were used. And that means that there is work to be done to educate researchers about referencing data, as well as collaborate with publishers to ensure that the references are passed to Crossref in a structured format. So while we know that our XDD citation tracking is likely missing data citations due to the fact that a number of publishers relevant in our domain do not have their articles indexed in XDD, it does capture more information than we would have otherwise. So in some situations, DOIs were not assigned to older versions of USGS data, or were never assigned or never assigned to a data set at all. So public can also search for mentions of non-structured strings, such as a title. And this type of search generally works best with distinct titles and often requires some added QA/QC. So for example, the Protected Areas Database of the US was first published in 2009. The first DOI for PAD US was not minted until 2016. And then as of 2020, we found 100 publications that had mentioned PAD US, or Protected Areas Database of the United States, but only one publication mentioning the assigned DOI. So let's take a closer look at PubLink and how it works. So PubLink can accept 3 types of parameters to search for relationships between data citations and publications. So first, the dataset search term, such as the dataset title. Next would be the dataset DOI. And then finally, it can search for a DOI prefix for an organization or repository. And I'll show examples of each of these in the following slides. So in this example, we are querying XDD for mentions of 2 dataset title names, PAD US and Protected Areas Database of the United States. These are 2 common ways that users refer to this dataset. In our search query, we use the parameter account for spaces down here equals to true. And that gives us a list of possible search terms to query that have a space added at each index position to help us address the issue of words being split due to page breaks. So for example, if our initial search term was fun, we'll search for fun, F space UN, and FU space N. Once we run the search query, we simplify and restructure the output using this XDD mentions method here. And printing the first two mentions looks like this. We see the XDD article ID here, the publication DOI if one exists, the search term that was found, that's here, and then the snippet of the publication where the search term was found, and that's this highlight down here. So searching for full DOIs is essentially the same as the dataset title search, except you set is DOI, that's down here, is DOI equal to true, which helps with properly formatting the DOI. And the results look the same as well. One thing that you can do with the results from the searches on DOIs or DOI prefixes is to restructure the mentions to match the DataCite schema for storing identifier relationships. And we use this feature to easily add our findings to our DataCite DOI metadata. The last search is the one that we use for our automated tracking pipeline at USGS and is the most specific to USGS. So for this type of search, we use the USGS prefix 10.5066 as the search term. When we simplify and restructure the output data, we use this, the search type equal to USGS instead of an exact match. This search type searches for USGS DOIs, which have a specific format, which allows us to refine the search and rule out any false hits. So the format for USGS DOIs is the 10.5066 prefix followed by 8 alphanumeric characters. And this allows us to look for mentions of the prefix where the term starts with 10.5066 and contains 16 total characters. For organizations that have a specified format for their DOIs, they could easily add a search type to public to account for their format. To account for some of the uncertainty when doing this type of prefix search, we've added a certainty variable to allow us to determine how confident we are that the mention that we found is truly a DOI. We also verify that the supposed DOIs against our DOI database. And then although we have some code to help improve our level of certainty based on the structure of our USGS DOIs, please remember that you can use Public to do exact match searches for any DOI as well. Okay, so next I wanted to do just a quick Slido poll to see if we're unique in having this kind of set format for DOIs that allows for us to do this type of search. I want to see if there are others that have a specific format for their DOIs, other organizations. And so I believe we've started the survey. And if you go into Kiko chat, there is a Slido tab, and that will allow you to get over to the survey to fill it out. And then I'm curious if you do know that your organization has a set format for DOIs, if you could describe what the format is, I would love to see that as well. So I'll give folks a minute or two to jump over to there.
Yeah, I have the link. I got it.
Are you able to display the results, Jonathan?
Yeah, let me
Okay.
the screen. It's trying to contact me, of course. We do have to move on to the next presenter in just a minute.
Okay, well, how about I just finish my last slide and then
Okay.
we can take a look at the results. So
Right.
my last slide is here. How can you get involved? So first, test out PubLink to find data for your organization. Next, contribute to PubLink source code, particularly if your organization does have a particular format for DOIs. Next, let's also continue working to use these publication dataset relationships to improve usage-based discovery of earth science data. And finally, we can provide feedback to publishers on how DOIs are currently being mentioned in their publications. So with that, I will wrap up. I'm happy to answer any questions and looking forward to our discussion later. And I have my contact information here on the slide. So thank you very much.
And I'll just plug that one of the breakout sessions will be on this, the DOI structuring concept that Madison brought up. So now we have to move on to our next presenter. We don't have time for questions, but we'll have a discussion in that breakout. Julia Lane, please share your screen or your presentation with us. Julia is the co-founder of the Coleridge Initiative and has been working. Tyler Christensen invited her to present because of her collaboration with NOAA. So without further ado, thank you, Julia, for coming.
Thank you so much. And I'm sorry, I have to jump at 11:55 because I have to go teach. I'm a professor at NYU as well. So my apologies. By way of context, I should also say the reason I've been working with NOAA is I was half-time at the White House working on the federal data strategy. And I've been very involved. I'm on a couple of advisory committees, which are pushing many of the ideas that I was just absolutely thrilled by these two presentations. It's like, thank you, Tyler, for getting me to come in, because I think we can make common cause here, and you'll see why. So here's the context within which I've been operating. You may be aware that the Evidence-Based Policymaking Act was passed. Title II of that act required agencies to put data inventories up, engage the public, expand the use of public data assets. And that's how I kind of backed into this. I've spent most of my career building large-scale data infrastructures. And part of the lesson I've learned with that is you've got to, I'm an economist by training, so I'm probably a fish out of water here, but one of the things I've learned, regardless of the discipline, we're all respond to incentives. So I'm going to talk about how we've been building an incentive structure to incentivize agencies, researchers, publishers to achieve our common goals here. And remember, the driving thing here is that the CDO Council, Chief Data Officer Council, GAO, Congress is requiring action on this. The other point is it's an unfunded mandate currently. So trying to figure out the lowest cost message to do that. Obviously, I was a Fed when at National Science Foundation, when the Obama administration had the Open Data Act. That was heavily criticized. Those of you who were around then will remember what the issues were. The core challenge as an economist is in Econ 101, we teach that if you mandate things, like our example is always a Soviet nail factory. If you mandate that nails are produced by volume, you get one big nail. If you mandate by quantity, you get 1,000 little nails. So the idea here is to create an incentive structure. We could go to the hardware store and we get nails of every quantity and quality, depending on what the market indicates. So how do we go from a response like this, which is put out information about data, right? That's clearly responding to an Open Data Act. So we put out data by how it was produced, kind of like a bookstore 20 years ago put out books by the way they were produced, ISBN number, title, or you could look in a citation catalog. The genius of Jeff Bezos and why he's a gazillionaire is he figured out how to put together an incentive compatible system where people provided information about data by use. So that's what we've been doing. We've been figuring out, with the help, obviously, of a lot of agencies, including NOAA. Tyler is fantastic in this area. How can we describe how data are being used, and then from creating exactly the link that you've been talking about is the link between data sets and publications. The challenge is, as you have pointed out, researchers aren't going to do it. It's extra work. They don't have an incentive to do it. Even, you know, when I have to write reports for federal agencies who funded me, they try and make me do it, and I do the minimum possible. So how are we going to make this happen? So let's figure out how to create incentive structures. Researchers have no problem with strutting their stuff about the publications they've generated because they get credit. They're grants that they've provided because they get credit. What we want to do is to take advantage of this Evidence Act to create credit for agencies, for researchers and the publishers, and then that provides value to the taxpayer, and that gets OMB attention, that gets GAO attention, that gets Congress's attention, and that's where the resources are going to come from. They're not going to come from the abstract, just saying data are important, send money. We got to figure out the incentive structure, and so we've got to figure out how to make the case. So that means, and every time I built a national data infrastructure, which I think is why I got pulled over into the White House, is I start with the value proposition and then everything flows from the value. So the good news is that all the plumbing is in place. And actually, I now have additional screenshots to add to this because you guys have done such a brilliant job of adding to that plumbing infrastructure. But here's the problem. People don't cite the publications, the data sets in their publication. And I went back and looked at my articles, and I've created quite a few data sets in my time. I never cite them. The only way in which you can find them is actually to read the publications. Now, you as a human being can read that and say, oh, that's the data that they used. How can we build an automated approach to get researchers to find the publication, the data sets that are cited in a publication? Well, this is a machine learning natural language processing problem. So what we did with NOAA, with USDA, with NSF, who are our core agencies, as well as now the Department of Education, we did what any reasonable person would do. We ran a Kaggle competition. We had 1,600 data science teams. And I should say Schmidt, Futures, Sloan Foundation, Overdeck Family Foundation, McGovern Foundation funded a lot of this activity. And it turns out you could get a lot of people interested with $90,000 in prize money. So it turns out, I thought this could be done. This was actually the third competition we ran. We learned how not to do things a couple of times, but this was very successful. So you could go on to our Show Us the Data site. I'll give you the slides, the links at the end. It could be done. And here's an example of the output. So here's the different publications. Now you wouldn't think, this doesn't look like a data set, but NOAA identified it as a data set, and you can see the machine learning models were able to identify it. Some of them didn't, others did. Turns out the reliability of the pool, I'll tell you in just a minute, varies. But the point is, we can read 80 million data sets, 80 million publications, and find the data sets that are cited, even without necessarily knowing what the data set name is. And that's important because a lot of data sets may not have names, or we may not know what we're looking for. If you take a look at the paper, this is forthcoming in the Harvard Data Science Review. You know, we you can see an analysis of the precision and recall of the different approaches. But obviously we're going to want the machine learning models are pretty crude at this point. We took the top 3 machine learning models and we're applying them to publisher corpora to pull it out. Some of them are going to be right, some of them are going to be wrong. We've got a validation tool that the subject matter experts, including NOAA, for example, are going in and not coincidentally, that then helps improve the training corpus, which improves the machine learning models, which improves our ability to pull the information back. So that validation tool and having subject matter experts involved early on is an important piece. So what we did, and as I said, we ran the Kaggle competition, and then what we did was we handed the publication data set dyad data set over to the agencies. We're building an API over here, but NOAA developed a very crude data inventory. We did it with them. NSF went off and actually created a dashboard. USDA went ahead and created a word cloud. There are many, many other ways in which an API that pumps out publication dataset dyads, obviously with all the metadata associated with the publication, which is who's used the data, for what topics, when, from which institution, and so on, that it can be used for. Point is, we could do this. Don't need to be manual. My heart sang when you talked about the burden of doing it manually. We can at least get the process started. And then I've been married a long time. One of my fundamental discoveries is people love to correct you when you're wrong. So if you put things up, and that especially applies to husbands, you can put the information up and then they correct it, right? You got me wrong. The other thing is people like to get credit, and that's obviously what the Amazon.com piece. So one of the task forces I sit on is the AI task force. There are only 12 of us, but we're really, I hope, having an impact here. I co-chair the data committee for the NARE, National AI Research Resources, and you will see that we actually all the domains have the same problems. Very heterogeneous data, very poorly curated, no information about search and discovery. And so one of the things we're recommending, this was presented, so it's public, is a search and discovery platform. Right. So we've got the means, methods, and opportunity. Now let's go in for the kill, right? So here's the kill. Let's show how we can create value. And at the core, it's evidence to make decisions. So let's think about 4 areas. At USDA, you may have noticed supply chain issues. So climate-driven transitions in agriculture. What do we know about that? What does data tell us? Here's NOAA. I'd love to see a NASA example in here. Find the origins of life. I don't know, but use data. Education, workforce transitions, and of course, COVID. So we're at step 1. We've done the machine learning. We've been at step 2, engaging subject matter experts. And now we're doing 3, so you can develop bespoke tools. Been working with a bunch of different, we're pulling together interagency working group at OMB and OSTP to take advantage of the API. Dan Stanzioni, who you may know from the Texas Advanced Computing Center, he's on the NARE with me. And so we're working together to build the API and the user portal. So we're right here now. So it's just absolutely perfect timing to be at this conference. But the basic idea here is let's join with the economists and build a value ecosystem. That's why Jeff Bezos is a gazillionaire. He didn't force anyone to do anything. TripAdvisor doesn't force anyone to do anything. You just make it in their own self-interest. So here's kind of a simple visual of what could be done. You know, you could land on a place, you could say by a topic or for a data set. How do I want to view it? Which agency do we want to do it? NASA, see your name there, right? And then, you know, you pull down NOAA, you say, I want to know about slosh, I want to see it by this. And down here, have we missed your contribution? Click here to update. One of the other things, let's make it in their own self-interest, like publications and grants. You want to be on a leaderboard on data sets. So I was thrilled to see the leaderboard example, but if we have a cross-agency effort to respond to Title II of the Evidence Act, and we start putting those data inventories up, not in the abstract, but, you know, led by OMB, and that's partially code for your friendly OMB examiner, you know, building that capacity looks a lot of value. So closing out, and Gizem can talk about this a bit more in the breakout groups while I'm teaching. So get your agency involved in the upcoming interagency group. Send me an email for that. But then we're only going to get one chance to make a first impression. So we want the output from the machine learning models to be validated. So when they get fed into the API, it's not a bunch of garbage, because if we put out a bunch of garbage, people are going to lose interest. And I think if we have a cross-agency push, again, that's something that came up in those previous presentations, man, we're going to grab a lot of people's attention. Identify underreporting. We know the data are going to be wrong. First up, that's the point. That's where the husbands in you come out and love to correct us. And then that network tool was super cool. The first presentation was super cool as well. You've got a lot of the pieces parts, so it's a little bit like Steve Jobs, you know, when he invented the iPod. He didn't actually apparently invent the iPod. He just knitted together and pulled in a bunch of stuff from the ether. And I feel like we're there now. We have this imperative that the agencies have to respond to, that will resonate with the OMB examiner. We had the chief scientist from GAO, Tim Persons, speaking at this conference, and they're looking to look at the results. So that's where you can get more information. I guess I shared the slide. I can send you the slides after this. Okay, so.
Thank you, Julia. And do you want to introduce Gizem?
Gizem, can you come on off? There we go.
Yeah. Hi, I'm an economist by training as well, and I'm a senior research scientist at Coleridge Initiative, working with Julia on the rich context effort.
Oh, and Sarah asked a quick question. What search indices does this infrastructure rely on? Great question. So what we started with was the agencies identified the data sets in which they had the greatest interest and the data set aliases. So that we then used that to form the basis of the training data set for the Kaggle competition. And then the data set, the machine learning model learned from the semantic context of how those data sets were referenced. Does that make sense? And that's how, so it wasn't, so there were actually two things. One was a straight string search, but there's no standard representation of names. So it was also the semantic context. So what you'll see is they find data sets that were not part of the original ask, because the machine learning models could figure out, oh, that's looking at a data set. Getting access to full text, great point. We partnered with Chorus, like Howard Ratner developed ORCID. I funded that when I was at NSF, by the way, in the small world category. It was the full text of our articles, Simon. So we had an agreement. We started to work with the USGS data, but they don't have full text. We worked also with some open access publications from Semantic Scholar and so on for the Kaggle competition. For this, we're working with Science Direct and Scopus initially, and they have provided us access for the 84 million publications to the full text. Now, down the road, it's any full text, right? So you can look at Federal Register, you could look at newspapers, you'd have to train the model a bit differently. But the point is, we're at the beginning of a big journey. It took a long time for Amazon to get there, but by God, Jeff Bezos started and he got there. And that's what we have in mind here. Oh, good question. So this project, and Tyler will tell you, this has been a labor of love. It's been about 5 years, close on 6 years at this point. About $6 million in philanthropic foundation funds, which we've been beating on people's doors with, a lot of sweat equity. I would guess that it will take roughly that amount of work as well. And yeah.
So if I may,
great comments in the text, in the chat.
Julia, if I may add, for the software, I have done some work for how people are not really citing software as well. It's the similar issue. People do not cite, and even if they want to, they do not know how to cite software that's developed. So there was an effort called DEPSI. I'm going to put the link there. That was also funded by NSF, that tried to identify citations for software, but it's discontinued. So and I'm not aware of any other efforts right now, but that's also very interesting.
But the point here is, if we could get over the tipping point, the same thing happened with citations. People started to put the DOI in as soon as it increased their visibility. So the first step is making it a first-class asset, and then making it easy for people to cite the DOIs. Right now, there's no incentive to do it. But the technology's there, but the incentive structure isn't. So, you know, if you want to be at the top of the leaderboard, here's an easy way to do it. And the point of having the publishers involved is they can make it very easy to do at the moment crease when you submit a publication. So you could read the publication, say, here's the data set we think it is that right? And then propose a DOI. So, and why do publishers want to do it? Again, the incentive mechanism is there because they want to provide information about the data sets used to the reviewers and the editors, and they're going to want to have their publications highlighted by the agencies. And that's also where Chorus can help. Yeah, DataSeer, Sam Klein has been working on that. He's also been working on Wikidata. And those are all very useful comments. Yep. It's not Dimensions. Dimensions has their own proprietary thing. We tried to work with them initially. They're not really very, it's a little bit of a black box. And we had them write a chapter in in the book that is in the slides, but you'll see that there are some issues with Dimensions. I'll talk about that offline. Is that sufficient code for you?
I know you have to get going.
I've got to go.
Your class, so we'll let you go. But Gizem's going to be around for the rest of the session, and we'll start our next part of the agenda. Thank you.
I feel like a kid in a candy store. It's wonderful to meet you guys, Gizem, and you can get in touch with us anytime. Thanks, guys.
Thank
Bye.
you. So what we have planned now is a 5-minute sense-making session. So we're going to go just after I share my screen. I'm going to show the outcome of the first Slido poll briefly, and then we'll come back for a 5-minute sense-making where you can think about the presenters' talks. Whoops, I already went ahead. So here's the outcome for the Slido poll. 63% said yes, they do have a format for their DOIs, which is encouraging. That's more than I expected. And then there you can, I don't know if you guys can see the results. You should be able to. Here are just some of the responses. Here's the shoulder, for example, 8 alphanumeric characters. So that's very encouraging. At least there's some level of standardization.
How
Stop.
can I? Sorry, Jonathan, is it okay if I interrupt?
Yeah, that's fine. And then we need to move on with sense making.
Because I was just going to say, I think a lot of this has to do with the way that DataCite itself, like the random format is basically like, if you just ask DataCite to mint it for you, it just gives you that shoulder, and then I think the 6 or 8 character tag. So
okay, yeah, I know you've been looking into that. So that this can be a topic of one of the breakouts. So now we'll transition to the sense making survey. Please go ahead and go back on to Slido. There's a new question available, and I'm going to be quiet now. What we'll do in the background is you'll learn about the tool we'll use called what's next. You'll select which breakout, all that apply. So if you think all the topics are interesting, select all, and we'll open all the breakout sessions where people have interest. So please go ahead and fill out the survey, and we'll be quiet for the next 3 minutes. Hi, so I'd like to open the breakout sessions, but before we do, we need to get organized. It looks like from the results, we're just going to quickly on the fly assign these groups. We're going to do just one breakout for messaging, usage-based discovery, utility, and benefits. For all those people who selected that topic. In these other 2 groups, we'd like to open, so that would be 6 more breakout groups following those topics. So I'm going to go ahead and do that. Please use the next minute or so just to collect your thoughts and which one of these groups you'll participate in, because you have to select one, and how you'll contribute. So I'm going to open the breakout rooms in just 1 second. Okay, so if you can please select one of the breakout rooms that I assigned. I think I may have cut it, the last 2, combined them by accident, but that's what we have. So please go and follow the what, and what next. And please remember to come back in the last 10 minutes so we can do report outs.
This meeting is being recorded.
I think the so what there is that somehow we need to have a standard, a convention, something that will make it relatively easy to pull repos from different sources together for data set article relationships. And in terms of the now what, I don't think we came to a conclusion on who should start that standard. We did one last thing that that was mentioned before we got pulled back to the main room was that we may want to look into what's happening with the dataset citation community of practice.
Thanks, Chris. Now the structuring DOIs group 3.
Hi. Yeah. So we discussed, we went around and kind of discussed the different structures. We didn't make it through everybody in the room, but that they're using at their organization. And like NASA, they don't have a set structure across all of their DOIs, but they do track them based on, like, they have their prefix or shoulder, and then they'll include like the data set name, like Terra Modis or something like that, and that they might be able to use that bit to pull back all mentions of all those Terra Modis data. And then others had similar structures that USGS has, and so adapting public for those will be really easy. And let's see. Yeah, and it seems like there's still some manual processes going on around tracking data, and hopefully Public will help those organizations insert a little automation into their workflow.
Hey, thank you, Madison. So I didn't see anybody joining the crowdsourcing breakout. Correct me if I'm wrong. So if that's true, then we can just move on to the research interests, the topics and finding breakout 5. Was there any takeaway points you want to share with us?
Well, I guess this is Jennifer Wei. We were discussing more problems than coming to, solution, what can we do? But basically, we sort of bring out this dilemma, right? So when the usage-based discovery is based on the publication, but what about the data set that's new coming out? So there's not much of usage base there in the publication world. So what do we do? So we were sort of stopped right there. And the second one is if, when we provide the popular data sets through the usage base, is that a good idea to sort of guide the user? These are the most data sets that, that's being used in the publication. What about those data set that's not popular? So how can we influence user to increase the data access by using other data sets? So we were just sort of highlighting the problems. We didn't have time to talk about how can we solve that problem.
That's wonderful. We always need people to think outside the box. We can follow up on those and all the discussion points in our cluster meetings moving forward. The next topic was machine learning, and that I heard that there was so much interest in that. Someone was actually wanted to leave because there was too many people. So who wants to speak for that group?
I could give a quick summary. So there was just a lot of enthusiasm, especially about the Coleridge initiative and the models that were mentioned and that are being developed. I think there's a lot of interest from different agencies and university groups that would like to get involved in that and contribute. One thing we talked about also was just this idea of broadening the disciplines that are represented, both in the model products and things like training data. And for the now what, there might be some cool opportunities for the cluster to get involved in terms of contributing to things like resource development, model validation. And then at the very end, we kind of ran out of time to talk about the state of the art for how the models are performing. But I think there's a lot of interest in kind of unpacking like recall and other metrics for these models within particular agency use cases. So yeah, there's definitely more conversation to continue out from that theme.
Yeah, sorry, I see in the chat people aren't happy about the Zoom experience, but this report out's really vital so we can capture those high level points. So the last group, if I can find it, is architecture and data development. This is the group I melded together because of a mistake I made, but hopefully it was a nice whoopsie.
Well, there were 3 of us. It was a nice whoopsie for Doug and Doug. I felt left out, not being called Doug. And I apologize to the 2 Dougs that I added some editorial spin to some of this, but it was difficult because none of us were involved in the data discovery group initially. So the what happened sort of was just us talking. Basically, multiple services exist for data discovery. One of the challenges is that they all use different underlying architectures. So we use Neo4j. Doug was talking, there's Sparkle, there's Gremlin and Neptune. Like graph databases tend to dominate, at least as far as we can tell. But this is a challenge because to then try to harmonize these groups, you know, what do you do? Do you choose one technology over the other? Do you try to figure out a way to like pull these all together. And so it results in complexities in building out this larger knowledge graph. So if we try to start harmonizing these different groups, it's important because if we can't do this properly, it effectively leads to inequitable ownership of the knowledge graph. Some of the groups that are better funded basically can dominate that field, and there's no room for these other groups to come in effectively. So the ownership of and so this wasn't something that we explicitly talked about. This is my editorial spin, but basically the smaller groups don't have access to that knowledge and that the building of that knowledge base, and then they lose out because they can no longer show the metrics of data usage. They can't show that to their funding agencies and stuff like that. There's another, some of the work is being done with uncertain machine learning. So we are tagging things. We don't have certainty necessarily. Other work's being done through crowdfunding, depending on the group that you're working with. And I'm saying uncertain, not that like I don't trust it, but just that there is a level potentially of uncertainty in that tagging. And then a lot of the discovery portal work is being done through these disciplinary portals. So like ESIP is doing work with, USGS is doing the work on their USGS data, and like Ocean Network work is being done on Ocean Network data. Then we get to this like, really this harmonizing is going to have, we started talking about ways of harmonizing this, and basically everything that we were talking about was effectively a stopgap measure. So yes, like throughput, which uses Neo4j in a cipher, we can export our data in an RDF graph that can then be imported by someone else, or someone using Neptune can export it in various ways. And so we can share these graphs, but that doesn't really solve it. So what actions make sense, but doing that sort of starts getting at some of these underlying problems, and potentially we can start figuring out more thorough ways of doing that in the end. What actions make sense? Driving practical use cases for harmonizations. So like, instead of just sharing the stuff, like why are we sharing it, and coming up with really realistic use cases for doing this broader sharing. Ensure breadth of representation at leadership levels.
Wow, Simon, yeah, you guys were very productive. Thank you so much, everybody.
Yeah.
And this is the end of our time here. I just want to do a quick takeaway of the discovery cluster. It sounds like we have a lot to talk about. So please come to our next discovery cluster session, or a meeting, which is next month in February. Look on the ESIP calendar. And let's continue this discussion. We'll look forward to having new participants come. Thank you very much. Sorry for cutting you off, Simon.
That's fine.
Continue if you want. People may want to go to lunch, but you can finish your last point.
I think we just wanted to say, like, how do we come to this decision of what is the best technology, or what underpins our choices of technology for these, rather than just like our developer knows how to use this. How do we come to a solution that says it's not just our developer, it's the community? What is the best solution?
Right, and that's part of the convergence. We're not there yet. And eventually, I hope we do. We get somewhere where we can all use the same data format, or perhaps even the same technology for recording this information. Right. So, after hours, any other comments or thoughts since people are hanging out?
Yeah, I just wanted to quickly draw attention to the 2 usage-based discovery posters that Chris just mentioned in the chat, are going to be shown today at the research showcase. So check those out this evening as well for more discussion. Yeah.
Awesome. All right, well, thank you, everybody. I guess that's a good closing note. So thanks for a successful session, and we'll see you later.
Thanks for leading, Jonathan. That was great.
Yeah.
Thanks, Jonathan. That was great.
That was awesome.
Thank you,
Thank you
Chris.
very much.
Thank you.
Bye, everyone.